We all take it for granted, right? You hit the brakes and your car stops. But inside that brake pad is a whole world of material science. And it seems the secret ingredient is actually fiber.
It really is. You can think of a brake pad like concrete, and the fibers are the rebar holding it all together. They're what give it the mechanical strength to not just crumble under immense pressure and heat, but they also have to be stable, bond well, and not wear out the brake disc itself.
So getting that balance right is everything. Now, the choice of these reinforcing fibers seems to really change the game. I see things like glass fibers are common, but then you have these high-tech organic polymer fibers and even pan-based carbon fibers for high-performance uses.
That's a great overview. And the physical shape of the fiber matters immensely. For instance, many organic polymer fibers are naturally curly, unlike straight glass fibers. That little curl allows them to interlock and distribute much more evenly throughout the material, which means more consistent performance.
So when we talk about the difference between, say, glass fibers and those high-end pan-based carbon fibers, what's the real-world performance implication for a driver?
Well, the so what is critical. If you're driving a standard family sedan, cost-effective glass fibers are perfectly fine for your daily commute. But for a high-performance sports car on a racetrack, you need extreme heat resistance and stopping power that never fades. That's where pan-based carbon fibers are non-negotiable. They're built for that abuse.
Got it. So we've seen how glass and carbon fibers offer distinct advantages. What about some of the newer or more niche fibers entering the market, and what challenges do they address?
This is where it gets really interesting. You've got things like paper-based fibers, which sound low-tech but are amazing for disc brake pads. They're cheap and work incredibly well in new water-wet manufacturing processes, which improves friction stability and gets rid of that post-production dust. Then you have metal fibers, like steel or copper, which are basically added to boost heat resistance and toughness.
You mentioned the move away from asbestos earlier. How do these new inorganic fibers like sepiolite or FKF connect the dots between environmental health regulations and maintaining high friction material performance?
That's the core challenge they solve. For decades, asbestos was the go-to because it was fantastic at resisting heat and adding strength. The problem, obviously, was the massive health risk. So these newer inorganic fibers are engineered to mimic those exact properties: heat stability, high strength, but without being carcinogenic. It's a huge win, allowing manufacturers to meet safety laws without sacrificing the performance we depend on.
Absolutely. It's clear that fiber innovation is constantly driving the evolution of friction materials. So, to wrap up, what are the absolute must-know takeaways from this discussion?
I'd say there are 4 key things. First, fibers are absolutely essential for the strength and performance of friction materials. Second, the ideal fiber has a tough job. It needs to be stable, heat, resistant, and environmentally safe. Third, the type of fiber dictates the application cost-effective glass for daily drivers, superior pan-based carbon for high performance. And finally, innovation continues with materials like paper-based fibers, improving processing, and new inorganic fibers, providing safer, effective alternatives to asbestos.